This is an introductory revision video for the GCSE Chemistry topic of bonding, which comes up in the first paper of AQA GCSE Chemistry and Combined Science. By the end of this video, you should be able to define the terms element and compound, define the terms atom and molecule, explain why atoms bond in the first place, name the 3 types of strong chemical bond, and identify which type of bonding a substance contains. You should know from Unit 1 that there are about 100 different elements listed in the periodic table, and the thing that makes each of these substances an element is that it is pure and it only contains one type of atom, which is different to the atoms of another element. So if we looked at a picture representing hydrogen, all of the atoms in this picture are the same. They're all the same size, they're all the same colour. If we compare that to compounds, compounds are substances made from more than one element, so they contain more than one type of atom. And here this is represented by circles of a different colour and a different size. These atoms need to be chemically combined, or we might call it bonded together, in fixed proportions. So in this picture of water here, there is always one oxygen atom for 2 hydrogen atoms, and we can show that using a chemical formula like H2O. An atom is the smallest part of an element that can exist. Now, that doesn't mean that there's nothing smaller in the world than atoms. We already know that those atoms are made up of protons and electrons and neutrons. But if you take an atom and you break it apart into its component parts, well, one of those parts on its own is no longer the element. So if I've got some oxygen and I have some oxygen atoms, when I start splitting those oxygen atoms apart into protons, electrons and neutrons, we wouldn't call that oxygen anymore. Now, those atoms can join together to form molecules. So a molecule is a group of atoms that are covalently bonded together. And if you're learning about this for the first time and you haven't met that word yet, don't worry. But the important thing is that only nonmetals form covalent bonds. So you can see in my picture of hydrogen here, each individual hydrogen atom has a paired one that it is joined with, it's bonded with, and that makes a molecule. One thing that we often don't talk about a lot at GCSE is why atoms form bonds in the first place. We just sort of assume that they do, but there is a reason. Everything in the universe tends towards becoming more stable. Now, that doesn't necessarily mean that it's trying. We're not talking about atoms having thoughts and feelings, but in the same way that an object that is off balance will tend to fall over and reach a more stable position, so will atoms and molecules move in a way that makes them more stable. And this applies both to individual atoms and also to more complex substances. Now, if you've studied bonding at all, you might have heard of something called the octet rule, or you might have been told that an atom is gaining or losing electrons to have a full outer shell. So having a full outer shell is one way of becoming more stable. And as far as we're concerned at GCSE, it tends to be the main way, but there are others as well. So for instance, if you form stronger bonds, then the new substance will be more stable than a substance that has weaker bonds. But all of this comes back to this idea that atoms are tending towards becoming more stable. Now, there are 3 types of strong chemical bond that you need to know about for the GCSE. And in a second, we'll look at how you know which one of those types of bonding is present in a particular substance. But firstly, their names. The first one is easy. Metallic bonding happens between metals. Then we have ionic bonding. And I just want to point out, it's not iconic bonding and it's not ironic bonding. And then our third type of bonding is covalent. And again, we see a lot of students making spelling mistakes in this. So it's not convalent with an N as the third letter, it's covalent. Now that you can name the 3 types of strong chemical bond, the next step is to be able to identify which of these types of bonding is present in a particular substance. And to do that, we need to look at the periodic table and identify whether the elements in that substance are metals, non-metals, or a combination of the 2. When looking at periodic tables in textbooks and revision guides, you've probably seen the metals and the non-metals separated by a staircase. And depending on which specification you've been following and who's been teaching you, you might have been drawing this in this position, or you might have been drawing it slightly differently. And the good news is it doesn't really matter which version of the line you've been drawing, because there isn't really a single right answer, because the periodic table doesn't really split cleanly into metals and non-metals. There's a group of elements in between called semi-metals or metalloids, which we don't talk about at all at GCSE, and they have some properties of metals and some properties of non-metals. So for the purposes of the GCSE, we only look at elements which are quite a long way away from the line. So we tend to look at group 1, group 2 and the transition metal block, all of which are definitely metallic elements, and then we look at the elements in the first few rows of group 6 and group 7, which are definitely non-metals. And the important thing about whether these substances are metals or non-metals is that metals form metallic bonds. So if you have a substance that only has elements from the left-hand side of the periodic table, it will contain metallic bonds. And then substances that are only made from non-metals form covalent bonds. And where we have a mixture of metals and non-metals, that's where we see the formation of ionic bonds. The one other element you should watch out for is hydrogen. Hydrogen, as you know, is a non-metal. It's a colourless gas, and hydrogen atoms form covalent bonds with each other, with carbon in hydrocarbons, with oxygen in water, and with halogens like fluorine. However, it's not drawn with the rest of the non-metals on the right-hand side of the periodic table. Instead, for the AQA exams, it floats here in the middle over the top of the transition metals. And you should be aware that it can form ions too, which is what it does when acids dissolve. So just watch out for this one. If a substance contains hydrogen, you should probably be treating it as a non-metal, even though it's not on the right-hand side of the staircase. So to complete this progress check, you are going to need access to a copy of the periodic table so that you can spot whether the elements involved are metals or non-metals. But now is an opportunity to pause the video and check that you've understood how to identify the type of bonding in a particular substance. So this first substance, Buckminster fullerene, contains 60 carbon atoms, and carbon is on the right hand side of the periodic table. It's definitely a non-metal. So because we only have non-metal atoms, it forms covalent bonds. Iron is obviously a metal, and oxygen is a non-metal. So because we have that combination of metal and non-metal, we see ionic bonds being formed. Water, containing hydrogen, which is a non-metal, and oxygen, which is a non-metal, contains covalent bonds. Methane, which is carbon and hydrogen, again both non-metals, forms covalent bonds. Iron, as we've said, is definitely a metal, so that's an example of metallic bonding. Carbon dioxide contains covalent bonds. Sodium chloride contains ionic bonds. Magnesium is another example of a metal, so it's metallic bonding. And sulfur is a non-metal, so that's covalent bonding. And finally, potassium chloride contains potassium from group 1, which is a metal, and chlorine from group 7, which is a non-metal, so that contains ionic bonding too. That's it for this introductory video, so hopefully you're now feeling confident enough to be able to move on to the individual videos about ionic, metallic and covalent bonding. If you did find this useful, then don't forget to like and subscribe for more GCSE Chemistry revision videos coming soon.